Good morning, everyone. Myself, Mr. Manjukiran, Assistant Professor, Department of Electronics and Communication Engineering, AJ Institute of Engineering and Technology, Mangalore. Today, we'll be learning about Module 4 of Computer Communication Networks. This chapter deals with network layer protocols as well as unicast routing. In the previous module, we have started with introduction to network layer, and we have learned what are all the different services provided by network layer and the addressing scheme. In that, we have learned about IPv4 addressing scheme, classful addressing, classless addressing, followed by how the addresses will be allocated to the user, and followed by the network address translation. So in this particular module, we will see the different protocols used in network layer. So my video will consist of one network protocol. In that we'll study about the datagram format, fragmentation, options, and security of IPv4 datagram. Followed by the second part deals with ICMP, that is Internet Control Message Protocol. In that, we'll see the different messages, debugging tools, as well as the checksum used in ICMP. And the later part deals with mobile IP. In that, we'll be learning about addressing scheme, different agents, the different three phases, as well as the inefficiency in mobile IP. So once again, the reference for this particular topic is from Data Communication and Networking textbook from Frozen. So let's move on to the content. So we have seen the TCP IP protocol. So wherein physical layer, data link layer, network layer, transport layer, as well as application layer are present. So now currently we are concentrating on network layer. So we'll be studying about network layer in this particular chapter. IPv4, that is Internet Protocol version 4, mainly consists of one protocol, that is IP, as well as three auxiliary protocol, that is IGMP, ICMP, as well as ARP. So it deals with four protocols. So one is the main protocol and three auxiliary protocol. So the main protocol IPv4 is responsible for packetizing, forwarding, and delivering of the packet, which we are seeing in the introduction part. So there is three auxiliary protocols, as I said. One is ICMP, which stands for Internet Control Message Protocol, which will be helping IPv4 to handle some errors that may occur in network layer delivery. So whatever the error occurs while delivering the packet, that will be handled by ICMP. Next one is IGMP, stands for Internet Group Message Protocol. This will be helping IPv4 in multicasting. So whenever the multicasting is carried out, so that time, so IGMP will be helping the IPv4. The last one is ARP, stands for Address Resolution Protocol. So this is the protocol which is used to link the network layer as well as the data link layer in mapping network layer address to the link layer address. So to link the address of network layer to the data link layer will be done with the help of ARP, that is Address Resolution Protocol. IPv4 is an unreliable datagram protocol. best effort delivery service. It provides the best effort delivery service, but it is unreliable datagram, which means IPv4 packet, it might be corrupted when it is transmitted, or it might be lost, or the packet whatever is sent may not arrive in the same order in which it has been sent, or it might be delayed. If the main concern is about reliability, then so IPv4 packet has to be paired with, or it has to be sent with any of the reliable transport layer protocols, such as TCP or UDP. For the better understanding, you can take the example of a post letter. So whenever we send a normal post, so since it's a normal post, so the delivery might be taken place, or it might take any time, so it may be late. But if you want it to be more reliable, that is, if you want it to reach within a time or without losing it somewhere, so we can go for something like register post, right? So that time, whatever the post has been sent, that will reach without much of a time, and we can trace it easily. In the same way, IPv4 simply, it is not a reliable. So if it we want to be more reliable case, then we have to pair that protocol with some other protocols. There are some protocols from the transport layer, we can see here TCP or UDP. So along with that, we have to pair the protocols of network layer, and then we can send the data so that it will be more reliable. IPv4 is a connection less protocol, that is user datagram approach. So we have seen in the previous case or the previous chapter. So user datagram approach is a one wherein it is connection less oriented. So the packet will be independent. So each of the packet, it might be of the same data, will be independent, and it will be delivered in multiple or different path. So the packet might arrive different instant of time. Let us move on to the format of an IPv4 datagram. So the data or the packet which is used in IP is called datagram. So we call that packet as datagram. So this is the one, or this is the slide which shows the format of a IPv4 datagram. We can see the packet which consists of header as well as payload. Payload is the thing but the data which the network layer receives from the transport layer. So that is the actual data. So that we call it as payload. And at the network layer, there is something called header. So this will be added at the network layer. So entire thing we call it as IP datagram. So one part which is received from the transport layer, and that for that the header will be added, and this entire data which is called as datagram will be transmitted to the destination. At the destination, once again at the network layer, this header part will be removed, and only the payload will be sent to the transport layer. So as you can see here, the datagram is of variable length. So as you can see here, it is from 20 to 65,535 bytes. So it is of variable length and consists of two parts. One is header and one is payload. So when it comes to the header part, the length of that might vary from 20 to 60 bytes. The length of the header might vary from 20 to 60 byte, and it will have the data, the head, that is header will have the data that is required, or this is essential for routing and delivering the packet. So this is the entire datagram that you can see here. It is of total of length 22 65,535 byte. So if we see the different parts in the header, so whatever is added at the network layer, the header, so it has got different parts. So it has got first one which is called as ver, which is a 4-bit, which is nothing but version number. It is of 4-bit, followed by there is something called HLEN, that is also a 4-bit, which stands for header length, that is length of the header. Next field is service type. This is the type of service provided. The length of that is of 8 bits. The fourth one is total length. That is the length of the datagram, that is represented in 16 bits. The next field is identification, which is consisting of 16-bit. We'll see what is this in the next slides. Next one is flag, which is of 3 bits. Next one is fragmentation offset, that is of 13-bit. All these three, that is identification, flag, as well as fragmentation field, are belonging to fragmentation of IP datagram. The next field is time to leave, the duration for which the packet will be live, that is of 8-bit. Next one is the protocol, that is which kind of a protocol is used, which is represented by 8-bit. Next field is header checksum. Once again, it is a checksum used to find the errors. So it is a separate other than for the payload, which checksum used for a payload. This is represented using 16-bit. Next two fields are our IP addresses. The first one is the source IP address, that is the address of the source. So the one which initiated or which going to send the data. Next one is destination address, so the packet where it has to be sent, so the particular destination IP address. Both are of 32-bit length addresses. And the last one is optional field plus padding field, that is any data to be added plus the padding data, that is of 0 to 40 bytes. So this entire thing will be available in IPv4 datagram. So with this, we'll go in detail with what is this field, what actually it represent, and what is the use of this each of this field in IPv4 datagram.